In this video, I'm going to have a look at a couple of things. So first, have a look at some changes I made to the 3D printed case for our boat monitor. I made it a bit longer so I can fit in a nicer looking component board, and also printed a mount for my bilge water level sensors. But most of this video is going to be about I2c interface. So first I tested out the original sensor components that I expected to use, that I talked about in the last video. I found it wasn't going to work, and so I ended up going down the route of using I2c as the sensor way to interface to the sensors for all my sensors. So both the temperature, air pressure, humidity sensor, and the ADC that I'll use for measuring the house battery voltage, and the bilge water level sensors. I also found there was a better way of interfacing from the I2c interface on the Pycom to my external component board, so have a look at that as well, because there's a challenge soldering up the tiny connections on the normal sensor here on the Pytrack board. Okay, a few more little changes here. So I've made the case a bit longer so I can fit in a better component board, so it looks a bit better. So that's what I'll mount the sensor resistors on. So by making that longer, I could also move this a little further away from the side, the power supply, so it'll give me more room to solder in the connectors there. I've moved the sensor connector down to the bottom and the aerial down to the bottom, so that should fit better in the boat when based on my boat fitting before. The other thing I did, I just changed the colour of the Lupincorp logo up there, so now it's British Racing Green. I also had first cut at making the mount for my bilge water level sensors. So these are the two sensors here, and I 3D printed the mount here. So the first one goes off after about half an inch of water in the bilge, so this will be pretty close to the bottom of the bilge. The next one will go off about when it's about 2 inches or 50 centimeters, 50 millimeters higher. That's where it starts to get worried. Probably means my bilge pump stopped working and I need to look at things. Otherwise I put some adjustable mounting here on the side, so when I put it in the actual boat I can move it up and down fairly easily to get it exactly the right height. One thing I found was these wires here don't really run nicely for this bottom one. I shouldn't have vertically aligned this, so I'll probably move this over a little bit, maybe make the case or the mount a little wider so that the wire from this bottom one never interferes with the float here, so it all goes straight up there. But otherwise I think it should work okay. Okay, that's my first attempt at connecting up the Pytrack board to my resistor components. So you can see I powered it on, the power light's going, but no flashing for the Pycom board, so I don't think this is working. So now I disconnected the component board, fired it up again. You see the power's turned on, and we see the blinking now, so this time the Pycom board's all working. So it must be something wrong with my sensor connector. Okay, let's work out what's happening on the pins here. So I've actually pulled the connector onto a piece of breadboard here. Black is ground, so I'm going to measure between ground and the first pin after that, which should be the 3.3 volts. So let's turn on the power, and that's looking pretty good. My voltage is pretty close to 3.3 volts, so that's doing the right thing. Let's just go through each of these pins. So this is the next pin here, and let me turn off the power again, turn that on, and we see this gets pulled down to 0 volts, which is probably a good indicator that that I/O pin's not being used. I don't see any activity on it. Let's try the next pin. I think this is probably I/O or pin 7 on the connector. Again, starts up getting pulled down to ground, so that's probably a good sign that that I/O is not being used. And finally let's look at this last pin, which should be pin 9 on the connector. Turn it on, and that one's interesting. You see the voltage has gone up to 2.5 volt and seems to be holding there. I'll let this just run through through a run of the program, so I'll just be going out, making the LTE connection, trying to send the data, and then we'll go to sleep with a large red blink. So it's connecting up to LTE. Okay, looks like it's sending the data with the green. And basically a couple of red blinks and power's gone down the board, so that IO's still holding some voltage on it as well. So that might be a IO pin I want to avoid, so maybe use there's another row of pins there with IO on them, so maybe I'll check one of those out to use as my third IO connection. So my original plan to use the external IO for getting voltages using the ADC doesn't look like it's going to work out, so I sent a note to Pycom and got this response that really the ADC and I can't really use the IO pins the way I expected. So this was my original circuit thoughts for getting voltages and bilge switch information, but really that's not going to work. So I'm going to switch over to just using I2c interface for getting all these IO connections. Okay, took the whole thing out of the case for a while because I need to work out how to do I2c. One of the tricky things was trying to find out a way to get the I2c SDA and SCL connections off this header. This header is really small, it's 1.27 millimeters, so I ended up having to make my own connection here. I really just, the soldering's so small I didn't want to try and attempt to do 6 pins. I could never find a header that would go in there, so I just used a 2-pin header to just get those actual pins off and put them over to a breadboard at the moment. And then I'm using the 3 volt and the 3.3 volt and the ground off the external pins I've already got underneath. So that should give me all the pins I need for doing I2c. Then I've got the actual I2c data pins coming over here to the breadboard and then connecting up to the SDA, SCL on the breadboard, connecting to my humidity sensor, and then just the power and the 3 volts going to the humidity sensor. Okay, this is my second version of a I2c interface. I actually found out that I can use the external connector pins underneath the board. So I'm using external IO 1 and 2 as the I2c data and clock lines, and I can show you in the software in a little bit on how you set that up. So I no longer need to use this tiny external interface connector. This was really too small for me to deal with, and I couldn't find the ribbon connector part to make it easier. So that goes off to the breadboard at the moment. So I've got a couple of pull-up resistors on the SDA SCL lines, a couple of 10 kilo ohm, bringing them pulling them up to the 3.3 line, and then I just take the SDA SCL ground and 3.3 volts, and that's our 4-wire I2c connector, so it's going to my humidity, temperature and pressure sensor. And I also wired in the ADC, it's a ADC1115 device to get voltages from my battery, and also test what state the bilge switches are in. So it's actually got 4 separate lines for measuring ADC voltages, so that should be good. This all seems to work. I'll show you in the code at working. So I should have this built well enough that I can now transfer this design back onto my protoboard, which is what I really should have done in the last video before I got too far ahead of myself. Okay, this shows the resulting circuit I'm going to build on the protoboard. Again, I've breadboarded it first, so I'm fairly confident with this one now. Just a note too, the pin designations can get a bit tricky. So between the pin designation on the actual Pycom board where it plugs into the Pytrack board, which is here, P0 to 11 on on the left hand side. These then map to the pins on the external I/O header, which I'm pulling out from underneath the Pytrack board. So these pin numbers here, 1 to 10, don't map directly to the pins on the Pycom board. So just be aware something like pin 9, which the Pycom board and the software knows it as, actually maps to external I/O 1, which is pin 6 on this external header. So with that being said, and I think I've called out what the two pins are on this diagram here. So I pull off pin 1 on the external I/O board, which is the ground, pin 3, which is the 3.3 volts there, and then I pull off pin 7 and pin 6, which is external I/O 1 and 2. On the Pycom board and in software they're known as pin 10 and 9, so you'll see those pin designations 9 and 10 being used in the actual software. Pin 10 is the SDA or serial data, pin 9 is serial clock or SCL. I pull both those lines up to the 3.3 volts on the board, you can see here with resistors, and then the 4 lines just go off to whatever I2c components I have out on the board. So that's where my humidity, temperature, pressure sensor is, and my 4-channel ADC is. The other thing I have to do is kind of like in the earlier circuit, is use a voltage divider to divide the house battery voltage, which again I'm going to allow it to have a range up to about 35 volts that it can read. Use the voltage divider, and there's the formula again down there, to really get 0.09 ratio of voltage the ADC measures to what the actual voltage on the battery is, and because I've got so much resolution, that should work for me. And then same thing, I've got two 10k resistors pulling the bilge switch ADC detectors on A1 and A2 up to the positive line, and then when I have these switch, I'll pull them down to ground. So that's what it's going to be measuring in the ADC for switch 1 and 2. So again, an ADC is kind of overkill for doing that, but it's easier to pull it off here than add some more lines out of here to measure it. Okay, let's have a look at the code I put together. I'll just comment out and bring things in as I go through the code. So first thing is I'm using I2c or I2c. You import it from machine, and basically you just need to set up an I2c object using I2c, a call to I2c. You pass it the role of the Pycom, the pins that I2c is going to be on. So by default, pin 22 and 21 are the I2c interface on the Pytrack board, but that's using that tiny I2c header, and then you set the baud rate, and I've just used 100,000. It can actually go higher than that, but I'll stick with that. And then to test it out, I'm going to do a scan on the I2c interface, and then just print out the results of that scan. And if I run that, so let's upload it and run it. You see here the scans finding the address of 3 devices, 8, 16 and 30. And that's basically the accelerometer and the GPS on the Pytrack board. So what I want to do is I want to swap over to using the external interface pins, and we just saw that the P10 and P9. So now it's going to go out and do a scan on those pins. So let's just save that, run it. This time it found 2 devices, 72 and 118. One of those is the humidity and temperature sensor, and the other one's the ADC. So we're on the right track here. Now let's actually bring the library so we can access first the humidity sensor. So I'm just going to uncomment that. I'm going to uncomment this line here where we're setting up a object for the humidity sensor, this BME 280, and otherwise I'm going to go out here comment out these lines here, which were the ones that were going out and interrogating the BME I2c sensor for the values. So let's run this. So we'll do a save and upload. And there we go. So it's picked up the temperature, 21.53 degrees centigrade, the atmospheric pressure, and then the humidity percentage is all inside. So 25 is about right. Okay, just looking at testing out the ADC here. So this red line, this is the line that's going to ADC 0, ADC input 0. So it's 1.67 volts measures there, and that's a simple divider at the moment. There's two 10 k ohm resistors here, one going between the high voltage of 3.3 volts basically, and the ground, which is here. So simple divider meets in the middle, so it's 1.63 volts it measures there, and we can compare that against the voltage that the ADC is measuring. This time enable the ADC. I'm going to disable the BME and just get the reading for the ADC this time. So this is calling this ADS1115 library, and both these libraries are available in Github online. I just pulled them down and then I'll make them part of my project. So let's try this. Do a save, do an upload. And it's measured the voltage, 1.629 volts, and that looks good. So I think we're ready to go. I'm just going to pull this code, or basically the two libraries, over to our boat monitor library, and then add it into the various sensors that it's pulling off, and have them transmitted through LTE back to our boat monitor back end.